All right, so this lesson is about combining polynomials, and polynomials just means many terms. And so it could have one term, two term, three terms. And so when I say combining, that could mean adding, subtracting, or multiplying. And so in the case of this first problem, this is a bit of a review from Unit 1. This is adding. And so when there's a plus sign between the parentheses, that just means combine them or add them. And we can only add like terms. So combine like terms. And so there's nothing to distribute in front of this set of parentheses here or here. And so they're really not necessary. And so we can rewrite this entire expression without the parentheses. Technically, we're distributing a positive 1, which wouldn't change anything since multiplying by 1 is the same. And so now we just collect our like terms. And so like terms have to have the same letter and same exponent. So x squared and x squared would be like terms. And so this is 1x squared and 1x squared, which would create 2x squareds. Okay, and then our x terms, there's only one of them. And so we'll just write down the x term next. We always go from highest exponent to lowest exponent. And then the constants would be at the end. So -4 plus 1 would give us -3. And so this would be our final answer. And then do not combine these. These are not like terms because they don't have the same exponent. And so always write your answer highest exponent to lowest exponent. Okay, this next one is similar, only now there's a minus sign. Okay, and so there's an added step, and that's to distribute. And so technically there's an invisible 1 here, and so we're going to distribute a -1 into the parentheses. Okay, and so there's nothing to distribute for the first parentheses, so I'm going to go ahead and write those down, those 3 terms. And then when you distribute a -1, -1 times 3 is -3x squared, and -1 times 5 is -5. It basically just changes the sign of those 2 terms inside the parentheses. Okay, and now we're right back to combining like terms. And so we have 1x squared minus 3x squared. 1 minus 3 is -2x squareds. And then we have a single x term. So we'll write that next. And then our constants are, 1 and -5. So that would give us -4. And you can use your Desmos calculator for this, just to number crunch. All right, this last problem is just a review of exponent rules because that's also part of this unit. And whenever you have an exponent outside the parentheses, as long as you are multiplying or dividing inside those parentheses, you're allowed to distribute it. And so this 25 would get the exponent, the x would get the exponent, and the y would get the exponent. So that's a big 25 and a small 1/2, a little 1/2. Make sure it stays that way because that's 25 raised to the 1/2 power, not 25 times 1/2. when we distribute to the x, he already had an exponent of -4, so if we're giving him a second exponent, we need to multiply those exponents. Same with the y. He already had a 5, and so now he also has a 1/2. We're going to multiply them. And so you can use Desmos to handle this. Just be careful when you're typing in 25 raised to the 1/2. That 1/2 needs to be in the exponent. And that would give you a 5. 1/2 exponent is the same as a square root. Okay, and then we can multiply the -4 times 1/2. That would give you -2. And then 5 times 1/2 would give you 5/2. Always use the fraction. Okay, and then before we commit to our final answer, if you see a negative exponent, that means that term needs to move to the bottom of the fraction. So leave the 5. You never get to move coefficients. The big numbers stay where they are, always, even if they're negative. And then y has a positive exponent, so he's fine. But x has a negative exponent, and so we move it to the bottom so we can make it positive. Treat negative exponents like negative attitudes. He doesn't like where he lives, so we changed his location, and now he's happy. He's positive. Okay, and so the next examples, we are going to be multiplying. Number 1, we were adding polynomials. Number 2, that's how we subtract polynomials. In the case of adding, you just combine your like terms. In the case of subtracting, you distribute your negative and then combine your like terms. Okay, a monomial just refers to a polynomial that's one term. So like this lonely x here, that's a monomial. Okay, binomial would be 2 terms, trinomial would be 3 terms, and then polynomial is just 1 or more terms. And so here we have a monomial times a trinomial. The plus and minus signs separate your terms. And so whenever you have a monomial, you're just distributing it into each of these 3 terms. So we're going to multiply the x by those 3 terms. I like to use a box when I'm distributing a variable to help me stay organized with the coefficients and the exponents. And so I'm multiplying x by 3x squared by the -4x and by the positive 5. You don't have to write plus signs, but you do have to write minus signs because that means it's negative. The other thing I like to do is fill in some invisible 1s for the coefficient and the exponents. Okay, and so now we're right back to what we were doing with our exponent rules, and that's multiply big numbers add little numbers. Anytime you're multiplying like we are here, you multiply big numbers, add little numbers. And so to fill in the boxes here, 1 times 3 is 3, and then 1 plus 2 would give us x3. And then 1 times -4 is -4, and then 1 plus 1 is x2. Multiply big numbers, add little numbers. 1 times 5 is 5, and then we still have the x1. And so for your final answer, writing it from highest exponent to lowest exponent, don't write the 1 in the exponent for your final answer. They'll count that wrong. Okay, so for number 2, the monomial we're distributing is -3n. negative 3n times this trinomial, these three terms. So negative 3n is getting multiplied by 2n squared, by 8n, by negative 1. All right, multiply your big numbers, add your little numbers. And you can use a calculator. Negative 3 times 2 is negative 6. And then I'm going to fill in these invisible ones. 1 plus 2 is 3, so n3. Negative 3 times 8 is negative 24. And then 1 plus 1 would be 2. Careful on this one. Negative 3 times negative 1 is positive 3. And then we still have the n1. So our final answer would be negative 6n cubed minus 24n squared. And since it's positive, plus 3n. You have to put a plus sign if it's positive so that you have an operation. Right? For number 3, the monomial is 2x getting distributed to this trinomial. So 2x gets multiplied by 4x squared, by the negative 8x, by the 3. Multiply your big numbers, add your little numbers, and so let's fill in our invisible ones. 2 times 4 is 8, 1 plus 2 is 3. 2 times negative 8 is negative 16, 1 plus 1 is 2, 2 times 3 is 6, and then we still have x1. So our final answer is 8x cubed minus 16x squared plus 6x. All right, last one. The monomial we are distributing is a negative 1x squared to these three terms. Times 5x squared times a 3x times a negative 2. Negative 1 times 5 is negative 5. X squared and x squared would be x4. Negative 1 times 3 is negative 3. X2 and x1 is x3. And then negative 1 times negative 2 is positive 2, and we still have the x2. So our final answer would be negative 5x to the 4th minus 3x cubed plus 2x squared. Okay, and so when you're multiplying a monomial times a polynomial, especially a trinomial, it would be a 1 by 3 box. These next examples, we're multiplying a binomial times a binomial. So I've got two terms, a binomial times two terms. I'm going to need a 2 by 2 box. And so x plus 4 gets multiplied by x plus 2. Every term gets multiplied by every term. Some call this process double distribution, since we're distributing two terms to each. Some call it FOIL. I like calling it the box method. It's all essentially the same strategy. The box just helps you organize it. Okay, and so same drill. I'm going to fill in the invisible ones for the coefficients and the exponents. And we're going to multiply our big numbers, add our little numbers. So 1 times 1 is 1. x1 and x1 would give you x2. 1 times 2 is 2 with an x1. 4 times 1 is 4 with an x1. And then 4 times 2 is 8 for the constant. This time, when we write out our answer, we have 4 terms to write. 1x squared plus 2x1 plus the 4x1 plus the 8. But when you're writing your final answer, if you have like terms, you need to combine them. And so when you combine your like terms, you're adding, so exponents don't change. That's why they have to be like terms. They have to have the same exponent because we're not going to change the exponent. Once you're done filling in the box, exponents won't change after that. Okay, and so our final answer would combine the 2x plus the 4x to get 6x. And we keep the exponent as a 1. So 1x squared plus 6x1 plus 8. And then for your final answer, do not write the 1s. Leave those invisible. So just an added step of combining your like terms. Okay, number 2, we have a binomial times a binomial. So 2m minus 3 and then 4m plus 2. I'm going to fill in the invisible ones. And so 2 times 4 is 8, m1 and m1 is m2. 2 times 2 is 4 with an m1. Negative 3 times 4 is negative 12 with an m1. And then negative 3 times 2 is negative 6. So I'm going to have an 8m squared, a plus 4m, a minus 12m, and a minus 6. My like terms are 4m minus 12m, which would be negative 8m. Okay, this next one, there's a very common mistake. There's a 2 outside the parentheses, but anytime you have a minus or plus, do not distribute. Exponent. You can only distribute the exponent if you are multiplying or dividing. If you are subtracting or adding, you cannot distribute. So make this note, remind yourself, do not distribute to minus or plus, because x minus 4 squared is the same thing as x minus 4, x minus 4. We need a box for that. Same if it said x plus 4, that would be x plus 4, x plus 4. You need to multiply every term by every term. Okay, and so when we do that, we're going to get some extra terms. 1 times 1 is 1. x1 and x1 is x2. Negative 4 times 1 is negative 4 with an x1. Negative 4 times 1 is negative 4 with an x1. And then negative 4 times negative 4 is positive 16. Okay, and so our like terms is negative 4x1 and negative 4x1. Negative 4 plus negative 4. When we combine these like terms, would give us negative 8. And so our final answer for this would be x squared minus 8x plus 16. And so if you don't make the box and accidentally distribute, you're going to lose that negative 8x and just get the x squared and the 16. Okay, this next one is k plus 5 times k minus 5. One times 1 is 1, k1 and k1 is k2. 1 times negative 5 is negative 5, k1. 5 times 1 is 5, k1. 5 times negative 5 is negative 25. This time, our middle terms, our like terms, is 5k and negative 5k. Because these have opposite signs, those cancel out. They equal 0. In this case, negative 4 and negative 4 don't make 0. Negative 4 and negative 4 make negative 8. But if they're opposite signs, they make 0. And so we don't even write that term. Our final answer would just be the k squared minus 25. So anytime you are multiplying two binomials together and they're the same, except one has a plus and one has a minus, your middle term is going to cancel out. All right, last two, we're going to throw in some trinomials. So on number 5, we have 3 terms times 2 terms. And so we're going to need to make a 3 by 2 box. Because we have 3c squared minus 6c plus 4. And then we have a 2c minus 1. Okay, and then fill in our invisible ones. Now we're going to have 6 terms to combine, or not necessarily combine, but for our final answer. So 3 times 2 is 6. C2 and C1 is C3. 3 times negative 1 is negative 3 with the c squared. Negative 6 times 2 is negative 12. C1 and C1 gives us C2. Negative 6 times negative 1 is positive 6 with the C1. 4 times 2 is 8 with a C1. 4 times negative 1 is negative 4. This time, we have a C2 that combines with this C2, but we also have a C1 that combines with this C1. And so for my final answer, I always look at the first term, 6c cubed, and the constant term at the end, and then narrow down my choices from there. And so for the middle terms, we're going to have negative 12 plus. Remember, when you're combining your like terms, exponents don't change anymore. Negative 12 plus negative 3 is negative 15. And then 8c1 plus 6c1 is 14c1. So just write the c. And so that would be our final answer. All right, last one, best one. We are multiplying 3 terms by 3 terms. We're going to need a 3 by 3 box. So we have k squared, 2k, and negative 1. And we have k squared, negative 3k, and 4. Filling in my invisible ones so I can see what I'm multiplying and adding. So 1 times 1 is 1, k squared, and k squared is k to the 4th. 1 times negative 3 is negative 3. K2 and k1 is k3. 4 times 1 is 4 with a k2. 2 times 1 is 2. K1 and k2 is k3. 2 times negative 3 is negative 6. K1 and k1 is k2. 2 times 4 is 8 with a k1. Negative 1 times 1 is negative 1 with a k2. Negative 1 times negative 3 is positive 3 with a k1. Negative 1 times 4 is negative 4. Okay, now that we've filled in the box, exponents won't change anymore. We're just combining our like terms. And so here I've got a k3 and a negative 3k3. Here I've got k2, k2, and k2. Here I've got k1 and k1. And so my first term is going to be the 1k4. And my last term is going to be the negative 4. For the k3 term, we're going to combine 2 plus negative 3, which is negative 1 k3. And then for the k2s, we're adding up 3 terms. Oh. Okay, so negative 1 and negative 6 is negative 7, plus 4 would give us negative 3. Of course, you can use a calculator. And then for the k1s, I'm putting plus signs to remind you that we're adding now, not multiplying. That's why exponents aren't changing. That's why we can only combine like terms. 8 and 3 would give us 11 for the k1 term. Okay, and then for your final answer, you can get rid of the 1s. I'm going to leave it for the notes. And so this would be our final answer.